Hi, I'm Don, and over the past couple of months, I've been trying to make the developer experience for TypeScript devs integrating with mobile money providers easier. I'll go into more detail about the project I've been working on in a previous video, so if you're interested, take a look at that. Auth is hard, especially when thinking of how to secure an SDK for your eventual users. So in order to find a solution that would work for me, I started by reviewing Superbase's auth implementation. A, because I had experience using it before, and B, because like the SDK I'm working on, it allows for self-hosting, meaning you can host your Superbase instance anywhere and point your SDK to it. When using the Superbase client, all you need to do in order to initialize it are passing two parameters. The first being the URL of the hosted instance, and then the second is a secret key or a publishable key, depending on if you're using it on the client or the server. And just like that, your client is initialized and you have access to all the different features provided by Superbase. Internally, Superbase takes your URL and uses it to make requests to your self-hosted instance, and also appends the anonymous key that you pass in as an authorization header. I thought this approach perfectly fit what I was trying to achieve, and so I adapted it into my SDK. So this code is pulled from my SDK, where I'm initializing a payments client, passing in a URL to the hosted instance and a secret or publishable key. Internally, the secret or publishable key will be added as a header for all outgoing requests, and the URL will be used as a base URL for all the outgoing requests. In order to understand how my authentication implementation works, it's important for me to explain the basic entity structure. I adopted a hierarchical structure for my entities, whereby we have the seller as the topmost parent, under which we can create stores, and then under stores we can create customers, products, and payments. And beneath that we have other entities reliant on either customers, products, or payments. Based on this structure, I adapted JWTs, which allow me to encode store-specific information as well as any environment information into a JWT. These JWTs can then be easily verified, as well as provide necessary information for the creation of other sub-entities like customers and products. There are two different kinds of keys. There's a secret key, which is only to be used on the server, and then a publishable key, which can be used client-side. And these two keys are generated and signed differently. For the publishable key, on application setup, that's when we are running the server for the first time. When running the application for the first time, a public-private RSA key pair gets generated, and these then get used for signing and verifying the publishable key. For the secret key, a random base64 string gets generated on application setup and gets used to sign and verify the secret key values that will come as part of requests from the SDK. Middleware is then used to control access to the different resources, handling both the secret key and the public key. In order to support payments being triggered by the client, I adapted the concept of ephemeral keys, which only get used in combination with checkout objects, whereby the ephemeral key gets generated when a checkout is generated, and and only gets used once when making a payment for that specific checkout. These are signed using the same key as the publishable key and include the checkout ID as a payload. Support for different environments is crucial to enable testing before production, especially on the payment side. In order to achieve that in my SDK, I've added the support for these different environments similar to what Stripe has. And these environments get encoded into the JWTs, which get used as either secret or publishable keys. So depending on which publishable key you're using, the resources you create or the payments you instantiate will be created under that specific environment. These environments also help with the control of access to different resources. The introduction of new authentication methods led to a lot of refactoring on the REST API and also changed the previous interface which the dashboard was interacting with. A lot of functionality on the dashboard has been broken as a result, and there is need to incorporate all these changes into the dashboard for it to work as expected. Implementing authentication was an important milestone and brings the project closer to a version 1 release. Over the next week, I'll probably be trying to fix the broken parts of the dashboard that I described earlier, and working on a number of other features that I have planned out in the backlog. Feel free to review the PR. I'll include a link to it in the description. I'll probably post some updates on my progress during the week. But until then,